So my question is, what happens if you get a gradient which is negative? Okay, so for example, if I get a gradient of -2, what do you think the difference is, positive versus negative gradient?
If we will put them, it will be like 2 plus 2.
Not quite. So I mean, let's suppose these are two separate lines. Let's suppose that I have one line with a gradient of 2. Now, the way which I'm going to interpret that is every time I move across by 1, I move 2 up. Okay, so if I move across by 1, I'm going to move twice that distance up. So in other words, that could be the gradient there. Okay, let's say for example. But what do you think -2 means? What do you think the gradient of -2 means?
Down.
Good. Okay. So every time I move across by 1 this time, so if I move across by 1, instead of going up by 2, so positive 2 in the positive direction, I'm going to move in the negative direction instead. Okay? So that's the only difference between a positive and negative gradient. The number still determines the steepness. Bigger number, more steep. But the positive versus negative gradient, all that means is one is going up and one is going down. Okay? So always move from the left to the right. Positive gradient means you're going uphill, negative gradient means you're going downhill. Is that okay? Good, fantastic. So very quickly then, let's have a look through distance and midpoint of a line segment. So see here, I've just simply taken the same A and B as we used as our example. I think we can really easily and quickly do distance and midpoint together. Okay? Now I'm actually going to start with midpoint. I'm actually going to start here. Because midpoint just simply means the middle point. That makes sense? Right? So which point lies in the middle of these lines? Oops, of these 2 points, sorry. So if I draw a line segment connecting A and B, which point lies slap bang in the middle of this line segment, do you think? Sorry? Yeah, can you give it to me as a coordinate though?
Maybe if we like add them all and divide them by 2.
Perfect. Absolutely right, yeah. So if you want to find the middle point, what you're going to have to do is find the average of the x coordinates, because the average one has got to be the one in the middle, right? That's what average means, it's the middle value. Okay, so if I find the average of the x coordinates, so in other words I take x1 and x2, add it together and divide by 2, that should give me the average x coordinate. And if I do the same for the y coordinates, so y1 and y2, add them together, divide by 2, that there should give me the middle point. Okay, that should give me the middle point, because average just simply means middle. So if I take the average, that's going to give me the average there. Okay, so in that case, it's going to be, well, 3 plus 5, which is 8, divided by 2, that's 4. That looks good, that's in the middle of 3 and 5. And if I want to find the y coordinate, well, okay, 1 plus 5, that's 6, divided by 2, that's 3. That's good, that's in the middle as well. That's in the middle of 1 and 5. So actually for this particular example, the midpoint, so let's call it capital M, the midpoint is going to be 3 plus 5, divide 2, and then 1 plus 5, divide 2. So the midpoint in that case is going to be 4 and 3. All good? Okay, so nice and easy for midpoint. Midpoint. Let's make sure I've written it in the right place actually. So that there was midpoint. Screw that. So the midpoint M is x1 plus x2 over 2, and then y1 plus y2 over 2. Perfect. If I want to find the distance, what I'm looking for is the straight line distance between those 2 points. Well, are you happy that really with coordinate geometry, all we're thinking about is distance across and distance up and down? That makes sense? That's literally what we're doing with coordinate geometry. So I guess if I draw in this distance across, okay, and if I draw in this distance up and down, are you happy I form myself a little right angle triangle there? Okay? So in other words, that distance across, well, we already worked it out when we were doing gradient, is going to be the difference in the y's. So it's going to be 5 minus 1, which is, sorry, the difference in the x's rather. It's 5 minus 3. So that distance there is the difference in the x's, that's going to be 2. And that distance there is the difference in the y's, that's going to be 4. Okay? How could I find that length there then? How could I find the length which I actually want, the straight line distance between the 2 points?
I forgot the...
Can you remember something called Pythagoras' theorem?
Yeah, that's what I want to say.
Ah, okay, good.
I
could tell you were thinking the right thing, so you could see because it's triggered some recognition there. So if I know that is, let's say that point, that side there is A, that side there is B, and that side there is C. Can you remember how to connect those 3 sides together?
C equals square root of A square
Good.
plus B square.
Excellent. Yeah, well done. Well rounded. Yeah, perfect. So I'm literally just going to do exactly the same thing here. Just bear in mind that A in this case is just the difference in the x coordinates. You happy with that? So A in this case is just the difference in the x coordinates. So x2 take away x1. And I've got to square that. That's what the formula says. Okay, so A in this case is just the difference in the x's. And are you also happy that B is the difference in the y's? So that's going to be y2 minus y1. So I've got to add that for B. And then just take the square root to find C. So in other words, I can say the distance between A and B should be given as this.